Tell you something?
Yeah.
So, do you guys know who Elizabeth Zerbier is? Okay. Her brother Peter. Do you know who Peter is? He was in Duncan's class. Yeah, they're friends. Okay, and he had a stuffed gorilla that he would bring to class, and he's about the size of Justin. He's a big stuffed gorilla who was Bob. And so they used to, because I give you guys extra credit if you work together on your homework, right? And you send me a picture of it. It's got to be outside of class. No one's done it yet. And we only got a few days left of the trimester. Well, they would send pictures of them doing homework together with Bob. So Bob was kept in here, so I took a picture of me lecturing to Bob and sent it to them. And then Bob was getting all the correct answers, holding the pen up at the board, videotaping with Bob. You know, you'd see Bob's picture. Bob sounded a lot like me, but so yeah. So you laugh. Is there a Joe in here? Already. We're done with this, right? Did we get to here? Or no? Oh, that's why you guys were so confused. Oh. Did we have this? What did we do yesterday? Oh my God. We were on number 5. For the very first time. Second period's ahead. Well, now I've let... What is M? 3. Justin. What's N, Justin? 2. M equals N plus 1. Would you agree? So it has an asymptote, but it's slanty. Now on this one you cannot do synthetic. Does everybody see that? Okay, you ready, Justin? You're going to lead the way. Okay? Outside here is going to be 3x squared plus 1. Inside, I don't know what you call this thing. I used to know. 2x cubed plus 5. This one's hard. Okay? Did we do this one? Okay, so what do you have to multiply x squared by to make it x cubed? What do you have to multiply x? Otherwise it wouldn't be linear, right? So this becomes x cubed. Now here's the hard part. Okay? What can you multiply 3 by to make it 2? Guess not hard for you, 2/3. And that's my slope. So I get 3x cubed, and then I get plus 2/3 x squared, correct? Right? It's not going to be underneath the 5. It'd be underneath the x squared. What's the matter? I know there's no x squared. Or it should be x. Okay, sorry. There should be a 2x cubed. And then I'm going to take the opposites and I'm going to add them. I'm going to get negative 2/3 x plus 5. But I don't care about this because this is the remainder. I care about this. So my slantintote, if Joel Consemius is listening, I should see if I can get a hold of him. Say, hey, I mentioned you on my YouTube feed. Right there is the slantintote. Okay? That's it. Because there's nothing I can multiply x squared by. Right? I'm looking for, my next thing is mx plus b. I'm looking for a constant, correct? there's no constant I can multiply x squared by to make it x. Everybody with me on that? So that's just the remainder. And if I did take the limit as x goes to infinity of that remainder of 3 of a negative 2/3 x plus 5 divided by 3x squared plus 1, that would go to 0 because the degree is bigger on the bottom than on top, right? The limit of that is 0. Ty, you got a question?
No.
You sure?
Yeah, I'm just a little confused.
A little confused at what spot? Then I need to fix it.
So you got negative 2/3 x plus 5, and that's a remainder, but for your equation, is it just y?
Equals 2/3 x. Because that's what I have up here as a quotient.
And then what happened to the remainder?
It disappears, it becomes 0 when I take the limit. Remember, this whole thing is a limiting process. All the y's head to this line, and this remainder heads to 0 because the degree here, you know, like when you do 8 divided by 5 and goes in there one time and you subtract and you get a remainder of 3, that's 1 3/5, correct? Or 1 plus 3/5, right? Well, this would be, it's really plus 2/3 x plus 5 over 3x squared plus 1. And when you take that limit, this goes to 0. And this will go into, it will create a slanted line, the rest of the y's. Does that help?
Yeah.
Okay. We cool, everybody? Alrighty, so this graph number 3, let me graph it on my machine here. And that's all I was going to do. And so number 3 is y equals and it is parentheses, equals, there we go, parentheses 2x plus 5 divided by 3x squared plus 1. There we go. So that's what that graph looks like. Notice here, see how this line is above the line, right? And you can see as I move to the right, now I'm at 20, I'm at 30, it's headed towards the y-axis. Do you see that? If I look to the left, do you see how it crosses the asymptote? But the asymptote isn't always. It's only starts when the numbers get really big. So you can cross an asymptote, which I never really knew of till I got into calculus, and then you can take a look, and do you see it's kind of headed up? You see here, I'm headed up towards the line. Do you see it rising right here? Can you see that? And as I go further and further out, it's getting closer and closer to the x-axis. Do you see that? But it crossed the x-axis right here. It has to because it has an x-intercept at a negative 2.5. But I don't care what's happening close. I care at what's happening at the ends, and it's headed towards the x-axis as I'm headed towards the ends, correct? So that's the line that I would have here. because I'm really more concerned what's happening with that end behavior. And then I'm going to put the other one in here. And I'm going to put in y equals again. And I'm going to have 2 divided by x to the third. And you can see on this one what's happening, right? I don't care what's happening in here. I want to know what's happening with the end behavior, right? And you can see that it's headed towards the x-axis also. And so it looks like this. And it's headed like this. And everybody understands that the x-axis is the horizontal asymptote y equals 0. Because it's frustrating for me to put a dotted line on the x-axis because you don't see it. You understand what I mean? So you'll see me write y equals 0 there. Everybody cool about that? And so I have these 3 things. First of all, if m equals n, and I'm going to have this, f of x is equal to ax cubed, or excuse me, ax to the m plus dot 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 over bx to the n plus dot dot dot. And if m and n are equal to each other, then the horizontal asymptote is y equals a over b. That's why you guys looked at me like, holy buckets, what's he talking about? Oh, I am so sorry. If I have where m is less than n, so the denominator degree is bigger than the numerator degree, then y equals 0 is the horizontal asymptote. If I have m greater than n, so that m equals n plus 1, so there's a difference of 1. You can think of it also like this, m minus n equals 1. Then y equals mx plus b. b is the oblique asymptote. And to figure that out, you're going to take b x to the n plus dot 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 and divide it into ax to the m plus dot dot dot, and you're going to get mx plus b. I'm going to put a fourth one in here. If m is simply greater than n, where m minus n is greater than 1. So you get 2, 3, 4, 5. No horizontal or oblique asymptote. I'm just hilarious. Okay. You ready? I'm shifting gears. So I'm going to put this equation in here. And I'm going to put y equals, and I'm going to type in square root. Oops, square root's got a q in it. Q Oh, I thought you did that automatically. Maybe I have to get the function. How do I get square root here? Yeah, okay, thank you. I knew there was somebody out there that I could count on. There we go. As soon as you hit the T, it pops up. Square root of 3a. Oh, I don't want that anyway. Why did I even do that? Owen.
You were saving it for later. You did not either first.
Yeah, if I could only have done that. All right. Now I want SQ, right? There I go. 2x squared plus 1. Look what happens.
Put -1 on the top instead of -2.
Okay, I don't think it's going to make a difference. Okay. Now look at this. As I go to the right, do you see how it becomes horizontal? And as I go to the left, do you see how it becomes horizontal? One's positive, one's negative. Would everybody agree? Alrighty. So, I have this. Okay? X is greater than 0. That means X is positive. So Julia, the numbers I'm going to input are all positive. So I'm going to input a 1. I'm going to square it. Have you done that in your head? 1 squared? And then I'm going to take the square root of it. What am I going to get? What if I put 2 in there? What am I going to get? If I put 3 in there, what am I going to get? So whatever I put in, I got back. Would you agree? Landry, that's the easy part. That is the part that is not confusing. Because we all love positive numbers. Because we understand positive numbers. Now, Caitlin, let's say I do this. What am I talking about?
X is less than 0 and negative.
Yeah, X is negative. Give me an example.
-1.
-1. So my input is a -1. I input a -1. I square it. Then I take the square root. Do I get a -1 out? I get what? A positive 1. It's opposite, correct? Let's put a -2 in here. So I'm going to do this. Do I get a -2 out? I get its opposite. I put a -3 in there. Do I get a -3 out? I get its. So what's my answer? I would, you know what? You and Josh Krebs gave the same answer. And you are correct. That's actually this is the definition of absolute value. Okay? However, there's another way, and I was giving the hint. It's the opposite of what I put in, correct? So if I'm putting X in, and X is negative,
Is that X times -1?
X times a -1. What's another way to write X times a -1? Okay? So if x is positive, when you put it in here, it'll be positive. When you put it in here, you're going to get the opposite, correct? And this means the opposite of x. I know we say negative x, but it really means the opposite of x. All right? So I'm going to do two limits. I'm going to do the limit as I go to the right, and I'm going to do the limit as I go to the left. So in this case, 1 over x is equal to the square root of 1 over x squared. If I put 1 in here, do I get 1 out if x is positive? If I put 2 in here, I'll get the square root of 1/4. I should get 1/2. If I put a 3 in here, I'll get the square root of 1/9, which is 1/3, correct? Now there's a reason why I have to do that, because the limit as x goes to the right, or where the positive infinities are, up here, I'm going to multiply this by 1 over x. But I want to get inside this radical. Because if you recall, if I got the square root of 2, to multiply the square root of 2 by a number like 3, it has to be the square root of 3, correct? That's the only way I can get a square root of 6. It's got to be inside a radical. So what I'm going to do here is I'm going to take the square root of 2x squared plus 1 and multiply it by the square root of 1 over x squared, which I can do because these two things are the same, aren't they? So this is going to give me the limit as x goes to positive infinity of 3 minus 2 over x on top. So I took 1 over x times 3x, got 3. Took 1 over x times 2 and got 2 over x. Down here I'm going to have the square root, and I'm going to have 2 plus 1 over x squared. Because I'm going to take that 1 over x squared, multiply it by 2x squared and get 2. And I'm going to take that 1 over x squared, multiply it by 1 and get 1 over x squared. Now I'm going to take the limit. This fraction right here is going to be changing. I'm going to have minus 2 over a humongously big number. Where is this 2 over this humongously big number going to? It's going to what? 0. So 3 minus 0 is what? 3. So I get 3 in the numerator. What do you think I get in the denominator? Not 2. Square root of 2. So now I'm going to come to this. Here's my graph right here. I'm going to put the equation, well, let me type in f of x. I think that's what I have to do. F of x. Oops, too much. Equals 3 divided by SQ RT 2. Do you see the purple line right here? Now, to the left it doesn't work, but as I go to the right, do you see how it starts to merge? Correct? If I pull it apart, you can see it's getting closer and closer and closer to that green line as I move on, right? As x gets bigger. Take a look at my x, it's 24. It's getting really, really close. I can pull them apart. Now x is 26, and when I slide it over and keep making it bigger and bigger and bigger, it gets closer, doesn't it? Right? So let's take a look. Look to the left. Well, what I'm going to have to do here is this, because it's negative, 1 over x squared is got to be the opposite of 1 over x, correct? Because what's going in here? A negative number. What's coming out? It's opposite, right? So now what I'm going to do is take the limit as x goes to negative infinity. I'm going to have 3x minus 2 times a negative 1 over x. And down here, I'm going to have the square root of 2x squared plus 1 times the square root of 1 over x squared. What does that give me? The limit as x goes to negative infinity of a negative 3 plus 2 over x over the square root of 2 plus 1 over x squared. Are we okay with this algebra? Which gives me what, Justin? Well, this is going to 0.
Yeah.
Added to a negative 3.
So it would be negative 3 over the square root of 2.
It's exactly that. A negative 3 over the square root of 2. So now I'm coming to this. And I'm going to type in here, and I'm going to type in EFG equals negative 3 divided by SQRT. You said 2, didn't you? And now take a look. Here's this horizontal. Again, I don't care what's happening. Oops, you have no idea what I'm doing. I don't care what's happening here. I care what's happening as you go way to the left. And you can see there's some gap here, right? But as I go to the left and x becomes more and more negative, those lines get closer and closer and closer, don't they? Is that helpful? Alrighty. Let's take a look at the next page. So this is going to be on a quiz and on your assignment. And what you have to do is break it into 2 parts. So you're going to say the limit as x goes to positive infinity. You're going to take the numerator and you're going to multiply it by what, Aiden? Yes, 1 over x. And I'm going to write this to help you out. 1 over x equals the square root of 1 over x squared, because if I'm going to positive infinity, x is always positive, correct? I'm going to the right. And down here, I'm going to have the square root. I don't know why I drew that line. The square root of x squared minus 1 times what, Aiden? The square root of what? 1 over x squared. So that's going to give me the limit as x goes to positive infinity. What do I have in my numerator? Aiden. 1 plus 1 over x. And down here I have the square root of what? Perfect. So what's that limit? Perfect. So I should get what as my answer for the next one? What should it be? Negative 1. So what's that going to look like? The limit is x goes to the left, where all the negatives live. And so this is going to give me x plus 1 times, and down here I'm going to have the square root of x squared minus 1 times. And up here, to give you a hint, Owen, I'm going to have the opposite of 1 over x, because I'm going to the left of this. So, Owen, what am I going to multiply here?
Negative 1 over x.
Negative 1 over x. What am I going to multiply down here?
Square root of 1 over x squared.
Okay, and that's going to give me the limit as x approaches negative infinity. What do I get on top, Owen?
You get negative 1 minus 1 over x.
And what do I get on the bottom?
1 square root of 1 minus 1 over x squared.
And the limit is what?
Negative 1.
Negative 1 over the square root of 1, which you didn't have to say because that's the same as a negative 1. Okie doke? Yes.
So if it's written like number 7's written, do we have to find the negative infinity?
Yes. Yes. If you don't do it on the quiz, I mark it wrong
Okay.
because you get to use notes. Correct?
Correct.
And here are my notes.
Okay.
Okay? So all you got to do is follow those steps. Okay? And I think I let you use a calculator. Okay. So now this, I'm going to take this and break it up as a multiplication problem. Okay, Ryan? So I'm going to take this finger. I'm going to take my thumb. What's the limit of that?
0.
0. Times. Here's cosine, Elijah. You're going to infinity. What's the biggest cosine ever can be? 1, right? It can't be ever bigger than 1. What's the smallest it can be?
Oh,
Negative 1, right? Doesn't it go like this? Right? It's a dance, isn't it? So the maximum is 1, the lowest is 1, so its limit is plus or minus 1. What do you get when I multiply that by 0? 0. So let's go to the machine. Delete, delete, delete. Y equals function cosines right here of x parenthesis divided by x. Now look at it. Enter. Let's look at it right here. Oops, Aiden's going. You did that last time. That was stupid. Why are you doing it this time? Gosh, can you just get over here? Now this is in close. And sure enough, it's got an asymptote at x equals 0, right? Because you can't divide by 0. But take a look as I go to the right. See how it's going below and then above, going below and above? But you can see it getting closer as you go to the right. It doesn't go up as high or low, does it? It's kind of weaving around the x-axis. Well, this number right here, where it crosses, is at pi over 2, because cosine is pi over 2. This is 3 pi over 2. This is 5 pi over 2. And then it switches the other side. So this is in the first quadrant. This is in the second quadrant. The second and third quadrant. This is in the fourth quadrant. Okay, you kind of got the ideas? And it flips back and forth. And you go to the left, it's also weaving around the x-axis. But its limit. So it's crossing an asymptote back and forth. But it's still the horizontal asymptote. Does that make sense? It's kind of cool. Trig kind of gets you some crazy things. This one right here. Jack, you're going to the right to positive infinity. And you're cubing whatever number you get. And then you're going to the left. And cubing whatever number you get. What do you think your answer is? Yeah.
bigger and bigger.
Yeah.
So, alright, infinity's not an answer.
No, it's not. Oh, yes, it is actually in this case. So what did you want to say?
Infinity.
Yeah, infinity is an answer. So what it means is as you're going to the right, it's getting incredibly big, correct? And you go to the left, it's getting very, very, very negative, isn't it? It's headed down. In other words, the graph looks like this, doesn't it? Isn't that the graph of x cubed? Yeah. And it's increasing the entire time, isn't it? This is where Aiden's answer is, if I took the derivative is 3x squared. Isn't the derivative always positive? Shouldn't it be increasing along from negative infinity to positive infinity? It doesn't ever turn around. So the first derivative is 3x squared, and the second derivative, which talks about concavity, is 6x. And if I let 6x equal to 0, I get x equals 0. Is that an inflection point? Did the concavity change? Is this concave down? Is this concave up? We're going to put all that together tomorrow. And I'm done for today.